Just keep swimming, just keep swimming. Nemo. Yes, right, Finding Nemo. Now, I bet you couldn't recognize this character from the movie.
Dory.
Yes, this is Dory. Now, I have another question for you. What is one trait that distinguishes her? Exactly, her condition on short-term memory loss. But what if I told you that Dory could have prevented her memory loss? Interesting, right? We didn't know it was possible before, but now it is. This is thanks to all of the technological advances that scientists have been developing over the years. But to know this, our starting point is this, the human body. The human body is made of roughly 30 trillion cells, and inside each individual cell we find our genes that were passed from the parents of our parents and the parents of our parents of their parents. Inside each gene we find our DNA. DNA makes us who we are. They are the building blocks of the genetic information that makes our body and individual organisms function correctly. DNA is in charge of giving me my freckles, giving him his amazing green eyes, and giving him all the genetics lined up to make this man look like this. Exactly, right? These curious spirals you see are in charge of your hair color, your eye color, whether you have a heart-shaped name, among many other things. I'm sure you have heard that DNA makes us unique among the 8 billion people on this planet. But you would be surprised to know that 90% of those 3 trillion bases of DNA we have in our body are the same in everyone. So yes, DNA is a copycat. It's a great role that DNA plays in our lives. By this, I don't mean being Jack in the Titanic or Harry Potter and the Wizards, but in understanding who we are, in understanding our family core, and the exact meaning that makes you, you. I could spend all day talking about DNA. Adenine, thymine, cytosine. But I see your faces and be like, what is the language she's stuck in? But don't worry, I'll try to translate everything you need to know to English. Now, let's talk about genetic diseases. What is that? Let me to give you a little bit of context, I will tell you one of the most common. For example, Turner syndrome, Down syndrome, albinism, cystic fibrosis, among many others. It was thought that people who were predetermined to have these diseases had no other option whether to live with them for the rest of their lives. But now, there are several options to know whether you have that gene mutation, even before symptoms manifest, or even before having children. You can now separate that mutant part of the gene in order to prevent any undesired outcome. But to know this, we first need to know where they are. It's like having a necklace with all white beads, except one red bead slipped in. Now it's a completely different type of necklace. But what if we were able to take that red bead out? Then it would be a gene mutation changed by a gene editing technique. But first to know, we need to know which one is the part that is damaged. This is when I want to introduce my little sister, Andrea. Andrea is 11 years old, and doctors would even say she's a walking miracle. When she was less than a month old, my little sister was diagnosed with a mitochondrial disease. So if you remember your biology classes, the mitochondria is in charge of turning sugar and oxygen into energy, aka being the powerhouse of the cell. And later on, this diagnosis was proven wrong, and my little sister was diagnosed with a muscular myopathy. That for us, regular speaking human, is having a weak musculature. Not like when you see your crush and your legs become like noodles, but actually weak muscles. So when my sister was 1 month, I was 7 years old, and my parents needed to take her to medical appointments, some in Mexico City, some even in the US. I had to spend some time alone. My sister had spent her whole life in physical therapy, but with the correct diagnosis, the correct medication, and the stimulation of her body, she could transcend it. Although it is hard for me to accept that she could have prevented all of her suffering if we were to isolate that little part of the gene. But it is possible to know that now it is possible, even for her future kids. Needless to say that all of these technologies have as a main purpose to prevent the suffering from congenital diseases, not to create any artificial or natural human beings. People will still get the flu, people will still be prone to catch COVID-19, among many other things. It has no option to be a robotic people. But any gene within the scope of its fabrication is within the possibility of being edited. How cool is to edit your own genes? By genes, I don't mean these type of genes. I mean these genes. How cool is to make something that can harm you, not to harm you? Okay, now let's talk about a genetic editing technique. CRISPR. I will tell you the scientific name. Cluster regularly interspaced short palindromic repeats. What? Yes, I see your face, don't worry. We'll stay with CRISPR. CRISPR has awakened a lot of controversy during its years of evolution, whether it's ethical or it's accessible for everyone. But despite all the society's opinions, I will tell you what scientists claim this gene editing technique works. But to understand this, you first need to know what is a genome. You can think of a genome as a puzzle that is complete and ready to frame. There are no missing pieces. Everything fits together. Or as a cake, not only the flour, the eggs, the butter, but the whole complete cake. Now that you know this, I can tell you that CRISPR is in charge of locating that damaged part of the cell. Just like Sherlock Holmes, or your mother when you didn't want her to find your report card. Then, CRISPR sends the Cas9 protein and cuts around the mutant part of the gene, just like scissors. Then, it leaves a natural DNA repair system. CRISPR has also the ability to turn certain genes on and off. But before we're able to turn any gene on or off, we first need to know how our body is encoded by our genes. Scientists need to know the specific location of those genes in order to be able to know how to move inside your body. For this, they have developed a technique that is genome mapping. You can think of genome mapping as the metro lines in New York City. If you use the map, then you won't get lost, and you won't miss out on the Rockefeller Center stuff. As you use a map to move inside a city, scientists use a map to move inside your body. Now, we have two types of genome mapping, the physical one and the genetic mapping. The genetic mapping roughly consists on knowing the specific information inside your chromosomes during the crossover of meiosis. So again, I will remind you of your biology classes. Meiosis is the division of the sexual cell. And the crossover happens when all of the chromosomes are in the middle of the cell. So, if the conclusion says that if they're far apart from each other, they might be prone to be inherited separately and are prone to recombination. And the other way around, if they're close to each other, they might be inherited together. The other type of genome mapping is the physical mapping. So as its name suggests, is to show the physical distance between the known DNA sequences in order to find out what is the best for you. Scientists will tell you, don't worry about that. You might be asking, why do I need to know my position? Why do I need to know how my body is encoded by your genes? This is exactly because of hereditary diseases that you might be prone to having, and you can know with this type of gene editing techniques. There are some diseases that you cannot inherit in a hereditary way, but your family lineage makes you more prone to getting this. For example, Alzheimer's. I'm sure you have heard of this disease. It has been heard that children whose parents suffer from Alzheimer's are more prone to getting this. But with this genome mapping, then you can know whether you have that gene mutation, and then you can start taking action. Not really to prevent it, but to delay its symptoms. It has been scientifically proven that you can delay its symptoms over 5 years, and reduce its power over 35%. This is according to the Prevention of Alzheimer's Dementia, EPAD. But you can only do this if you follow a healthy lifestyle, meaning no drinking, no smoking, doing mental exercises, and joining some medical trials. So it is possible. Just with the fact of getting to know yourself and having all the necessary information, things can be done. So this is when I want to remind you of my little sister. Yes, this precious little girl. Just as the best thing for her was to conduct the genome mapping, I will tell you that it's the best thing for you as well. There good and bad things to everything. The good thing is that you can apply to do one for your own. The bad thing is that the price ranges go from $400 to even $1,000. So it might not be within the medical budget for the majority of the world. Our body is a world full of wonders that it has not been understood yet, making each discovery groundbreaking. This you have here is your perfect little machine, and it is your only perfect little machine that needs to be taken care of, understood, and embraced. And to know this map will be your starting point. Thank you.